What's up, guys? In this video, we're going to explore how to factor quadratic trinomials when a is not 1, as well as dealing with some bigger numbers on factoring. We know that is where it can definitely get tricky with factoring, so hopefully by going through these 10 examples, you'll have a better understanding. I hope you enjoy.
So, all right, ladies and gentlemen, it's asking us to factor the problem, all right? So when we need to factor the problem, we need to write our expression as a multiple, or as the product of our two factors, all right? So that's all we're trying to do is trying to write this as a multiplication problem. So the first thing we want to do, the easiest way to write something as a multiplication problem is look at it and see, can you divide an even number out of it? Because look, if I say write 12 as a multiplication number, you can say, oh, well, 2 divides into 12, so therefore 2 times 6. Well, that is a factored form of 12, all right? I know it's not prime factored, but that's a factored form of 12. So we look at here and we say, what do these all have in common? 5x squared, a negative 18x, and a positive 9. So remember, last time or a couple times, we prime factorization them out and see what exactly they share in common. You can do that with all these if you want to, but I'll tell you right now, this 5 is a prime number. Negative 18 or a 9 do not have a 5 in them. So therefore, already I know that they don't share anything. This is an x squared, this has an x, but this term doesn't have an x. So automatically I know off the bat, they don't share anything, right? So we can't divide out a simple number. So we're going to use a method that's going to help us figure out how can we rewrite it as a product, and that's going to be use our x. So in our x, we do a times c and b on the bottom, where ax squared plus bx plus c. So a is our coefficient of our x squared term. So I do 5 times 9, which is 45, and then I get a negative 18. So now I need to think about what two numbers multiply to give me a positive 45, but add up to give me a negative 18. Well, when you start looking through the multiples of 45, you're going to get negative 15 and negative 3, all right? So, going back to what we've already kind of talked about before, we can represent that in two different ways, all right? We can represent it, one thing, guys, when we're factoring, what I want you to do is you can think about it as that's going to be your rectangle, and what we're simply trying to do is figure out what the two side legs are. So I need to figure out what these two boxes are as far as my area. So that's negative 15, and that would be a negative 3x. Or we can simply just rewrite this and just read 5x squared minus 15x minus 3x plus 9. All right, if you notice, this is the same as this, which really is the same as this answer. Because what's negative 15 minus 3x? Negative 18. So Markel, I didn't change the answer at all. This is equal to that, which is equal to this. So now there's two different ways we can find the answer. All I did, you see what I did, Jenna? All I did was I took my diamond, or I took my x, to figure out negative 15 and negative 3. Negative 15 times negative 3 gives me 45, which was a times c, and they add up to give me negative 18, which is my b. So now to figure out what the two binomials are going to be, we can take the inner box and say, all right, what two numbers multiply to give you 5x squared? Well, you could say x times 5x. 5x times x gives you 5x squared. 5x times what gives you negative 15x? Negative 3. X times what gives you negative 3x? Negative 3. Does negative 3 times negative 3 give you 9? Yes, it does. So if that way doesn't make sense, you don't say, oh, I don't like going from area to side lengths. You can also just write it all the way out and factor by grouping. So what do a 5x squared minus a 15x share? Do they share anything? You can say, yeah, they do share. They have a 5 and an x in common. So what I can do is I can divide out a 5 and an x. Therefore, leaving me with an x minus 3. And then here, I can factor out a negative 3. Because this negative 3 and a positive 9, I can factor out a negative 3 that will leave me with an x minus 3. So now I look at this whole expression and I say, what do these share? Well, Andre, they share an x minus 3, so I can factor out an x minus 3, and then what I obtain is a 5x minus 3. And what you'll notice is x minus 3, 5x minus 3. Exact same answer both ways. All right? So there's two different ways to solve by factoring.
That didn't make sense.
I'm sorry?
It didn't make sense.
What made sense?
From when you, after the big old X thingy, like, how you got all your 5x.
All I did was, do you see this? Is this mathematically different than that? No. So it's not mathematically different at all. It's just a way for us to rearrange this expression, because remember, we're trying to write, our whole purpose of this is to write it as a product. Does this times this, is that a product? Yes. Does this times this equal that? It does. So how do we get from here to there? Well, we can't factor the same number out of everything, right? They don't share everything in common. So we just focus on splitting it up. Factor the first two, factor the last two. All right? Or if you look at the area, all I did was, remember, you have the whole area here. Define factoring means what times what is going to give you your area. So if here's my area, you need to figure out what are going to be your two side lengths that are going to multiply to give you that. So again, what we're doing here, if you look at, all I'm doing is I'm factoring the first two terms, and I'm factoring the last, I'm factoring those last terms. So that's really all we're simply doing. Yes, Rosie?
So the answer is not going to be x minus 15 and x minus 3?
No, because watch. Listen, look at this. X minus 15 times x minus 3. Does that multiply to give you that? No. So that's why you can determine. If, Rosalind, we didn't have an a in front of here, yes, that's how we'd work our, we just find our x, right? And then we could figure out that these would be your two factors. But since I have an a, since I'm now multiplying by 5, we're going to have to factor out to get our answer. Okay?
Welcome, ladies and gentlemen. So what I'd like to do is show you how to factor this expression. Now, this one's not a very bad one that we're going to work on. So to go ahead and factor, and the reason why it's not a very bad one is because I see that the only factors for 5 are 5 and 1, and the only factors for 2 are 2 and 1. So I can easily probably go and do this in my head, and I'll show you exactly how I'm going to do that. Now, before I get to that, though, whenever I'm dealing with factoring, I always like my a to be positive. So I'm going to factor out a negative 1 first. So factor out a negative 1, and therefore I'm left with 5x squared plus, positive 5x squared minus 7x plus 2. OK, so now what I want to do is I still want to be able to see, can I factor this even further? So what I'm going to do is I'm going to break this down into two factors, right? Because that's basically factoring, is breaking it down to a product of its factors. And I know that to get 5x, I have to have 5x times x, right? And to get positive 2, well, I only have 4 different ways. I could, 2 different ways. I could do positive 2 times positive 1, or negative 1 times negative 2. And the position of those, it could be positive 1, positive 2, or it could be positive 2, positive 1. It could be negative 1, negative 2, or negative 2, negative 1. So I only really have 4 different cases that I can use to determine which one is going to be correct, or where the correct placement is going to be. However, what I notice is my middle term is negative, right? So since my middle term is negative, I'm not going to be able to multiply positive numbers and then add those positive numbers to make it negative. So I really basically only have 2 cases. Right? These are really only my 2 factors. Now again, so let's double check. Does negative 1 times negative 2 give us positive 2? Yes. Does negative 2 times negative 1 give us positive 2? Yes. 5x times x, 5x squared. 5x times x, 5x squared, right? So it works. So now what I need to do is just say, well, what inner and outer terms, when I multiply and combine them, are going to add to give me negative 7x? And what you'll notice is this one right down here works. So there you go, ladies and gentlemen. That is how you factor a trinomial by using your head. Thanks. Welcome, ladies and gentlemen. So what I'd like to do is show you how to factor this trinomial. And again, when looking in factoring, when we have a is greater than 1, one way we can look at this is either doing it in our head, or we could also look into applying our AC method. So when looking at the AC method, I have ax squared plus bx plus c. So a equals 6, b equals 1, and c equals 5. So when using the AC method, I'm just going to multiply a times c. and then put b. I want to determine the factors of a times c that multiply to give me a times c, but then also add to give me b. So a times c would be 6 times 5, which is 30, and b is negative 1. Well, what we notice is, let's look at the factors of 30. Now again, if the two factors are going to multiply to give me positive 30, but they're going to add to give me a negative number, that means those two factors have to be negative. So let's write out the factors of 30. So it'd have to be negative 30 times negative 1. I could do negative 15 times negative 2. I could do negative 10 times negative 3. And I could do negative 5 times negative 6. Right? Those are all the factors, as I believe. Yes, looks good to me. But the problem is, do any of these add up to negative 1? No. So therefore, this is not factorable. That is already in its simplified form. Thanks. Welcome. All right. So it's really nice when we have a quadratic when a equals 1. The operations are pretty easy to go through it. However, when we're factoring when a is not equal to 1, it gets a little messy. But that's OK. Well, remember, we're going to be graphing quadratics, which would be ax squared plus bx plus c. All right? And when we have a equals 1, when a is not equal to 1, the first thing I always tell people is, see if you can factor out a GCF. Because a lot of times you'll have a quadratic where you can factor out a GCF, and then your a is now going to equal 1. All right? But when a does not equal 1, there's kind of two different ways we can go about this. And I'm going to kind of show you the two different methods. One's kind of the quicker method that you can start doing in your head. And the other one's what I like to call kind of a foolproof method. It's going to work for every single type of factoring quadratic that you have, but it does take a little time. So the goal is to kind of start with that. We'll do it over here. Start with that first problem, and then work your way into so you can start doing it in by your head. Now, the important thing to always remember is you can always check your answer by factoring by applying them. So let's pretend our product is 2x minus 1 times 3x plus 4. All right? So let's pretend that's our answer. If I wanted to check my answer, remember, I can always go back and multiply everything out. So in this case, I have 6x squared plus 8x minus 3x minus 4. So therefore, I have 6x squared plus 5x minus 4. And you might be saying, well, what are you doing? What I'm doing is I'm creating a problem that I'm going to show you how to factor. And you might say, well, we already know the answer. I know, but I'm trying to show you the process. So let's go and take a look at the slow way first of all. Sorry. Let's go and show you the slow way first, and then I'll show you the quicker way that you can look at this. 6x squared plus 5x minus 4. All right? So the slow way is what I like to call the AC method. And what that means is, if you remember that by the factoring of when a was equal to 1, we could write up c up top and b down below. And what we want to do is determine what two values multiply to give us c, but then add to give us b. But now when we have an a, what we're going to have to do is we're going to have to do, well, what two numbers multiply to give you a times c, but then add up to give you b. So in this case, I have 6 times negative 4, which is going to be a negative 24. Now what I need to do is determine what two values multiply to give me negative 24, but then add up to give me 5. So to do that, a lot of times I'm just going to write the factors. I'm not going to worry about the negative here in a second. I'm just going to write the factors for negative 24. So I have 24. Got it? OK. So 24, so I could do 24 times 1, 12 times 2, 8 times 3, 8 times 3, and 6 times 4. And that's going to be it. Now, notice that I know these two numbers, if they're multiplying to give me negative 24, one of them has to be negative, and one of them has to be positive. However, since they're adding to give me a positive value b, I know that the smaller of the two numbers has to be the negative. So therefore, I make all my factors negative. And now I determine, out of those factors, which one of those add up to a 5. And that's going to be my 8 and negative 3. All right? So now what I do is I take my middle term of my original quadratic, and I break it up with coefficients of 8 and negative 3. So now I rewrite this as 6x squared plus 8x minus 3x minus 4. All right? So now what I've done is I've broken this up, and now I do what we call a technique which we call factor by grouping. So what I'm going to do is I'm going to group the first two terms and group the last two terms. And now what I do is I look at each one of those expressions and see what can I factor out as far as a GCF. Well, I look at here and I notice that they both share an x and x, as well as I can both factor out a 2. So I factor out a 2x, and I'm left with a 3x plus 4. Now, the goal when factoring by grouping is to get these to be exactly the same, what you factor out. So a negative 3x minus 4 is very close, but it's just not exactly the same as 3x plus 4. So in this case, what I'll do is subtract out or factor out a negative 1. So that leaves me with a 3x plus 4. Now you can see that these two terms are exactly, or these two expressions are exactly the same. So now what I'm going to do is factor them out again. So that's going to leave me with a 3x plus 4 times a 2x minus 1. All right? So the next method I'm going to show you is kind of a little bit different. And this one is going to be concerned with just kind of doing it in your head. And when doing a problem like this in your head, what we want to do is we need to determine what two values multiply to give us 6. So remember our 6x squared. So we know that those values could be 6x times x, or we could do a 3x times 2x. All right? Then what we're going to do, so we break apart the factors of 6, which are 6 times 1 and 3 times 2. Then we remember, because remember when you're looking at FOIL, when we do FOIL, the first two terms multiply and the last two terms multiply, and then you do the outer and the inners. But so we know that when I multiply these last two terms, that's going to give me a negative 4. So now I break up 4 into 4 times 1 and 2 times 2. And then all I'm simply doing now, where I know that now one of these has to be negative. I don't know if it's going to be the larger or the smaller at this point. But what I simply do is now just kind of do a guess and check. Should it be a negative 1 and a positive 4? Should I do a negative 2 and a positive 2? And what I'm going to do is when I'm checking my answer is I'm just going to take a look at what happens if when I add the outer terms and the inner terms. The inner terms and the outer terms. When I add those inner and the outer, because I already know the first terms at multiply give me 6x squared, and the outer terms are going to multiply give me negative 4. So then all I want to do is multiply my inner and my outer and combine them to see what's going to give me a 5x. Well, in this case, 6 times 24, or 6 times 4, that gives me 24. And then minus 1x, that's going to give me negative or positive 23x. So that's not going to work. And then what I notice is even if I rewrite this, so therefore, let's swap then the 4 and the 1. All right? Well, if I do 6x times 1 minus 4x, that's going to give me 2x. It doesn't matter how I write this. Or let's do 2 and 2. Again, that's going to give me 6x times 2 is 12x, minus 2x is 10x. All right, that's just not going to work, right? You look over here. This gives you 6x. Minus 4x is going to give you 2x, so close. But let's just go back and look at our answer and see that we have 3x. Let's do minus 1 plus 4. See why that one doesn't work. So again, we know 3x times 2x is 6x squared, and negative 1 times 4 is negative 4. But in this case, if when I multiply negative 1 times 2x, that gives me a negative 2x. And 3x times 4 is 12x. So again, those won't add up to 5x. However, if I swap 3x plus 4, obviously in minus 1. If I swap my values, you can now see that 3x times 2x is 6x squared. 4 times negative 1 is negative 4. 4 times 2x is 8x. 3x times 1 is negative 1 is negative 3x. 8x minus 3x is 5x, a positive 5x. And there you go. There's our solution. So there you go, ladies and gentlemen. That is a long-winded solution on how to factor when your a is not equal to 1. Thanks. Welcome. What I want to do is show you how to factor this trinomial. Now, when we're factoring trinomials, one thing we always want to do is see if we can factor out a GCF. But I noticed there's not a factor I can factor out of each one of those three monomial terms that I could use to factor them out. So what I'm going to do now is going to use some factoring techniques. And the factoring technique I'd like to share with you today is going to be called our diamond technique. So first thing, a trinomial, when we have it in our quadratic form, what we have is our coefficient of x squared is a, the coefficient of our x squared is b, and our constant, or our numbers, we're going to call c. Now, if I have it in quadratic form, I can factor the trinomial by multiplying my a times my c, and then putting the b on the bottom. So in this term, I'm going to have my a x squared plus bx plus c, as this is in quadratic form, obviously.
So my A times C would be 9 times 1, which is 9, and my B is going to be 6. Now what I want to do to find these two areas, or these two, areas of my diamond, or this little box, I guess I should say, what I'm going to do is I need to say what two numbers multiply to give me 9, so what factors multiply to give me 9, but add up to give me 6. And you can obviously see that your two answers are going to be 3 and 3. Now remember, those two numbers have to multiply to give me my A times C. Well, since my C is going to be 1, here I can just have them as my two x's. So it would be my 3x and my 3x. Therefore, I can set that 3x times 3x. Because remember, these two numbers have to multiply to give me 9x squared. Well then, my last two numbers have to multiply to give me 1. So what I notice is I have 3x plus 1 times 3x plus 1, which reduces down to 3x plus 1 squared. So the main important thing is just to use your diamond technique. Make sure if it's for my A times C, where my A is my larger number than C, I can multiply 3x times 3x. If I check this by foiling, 3x times 3x gives me 9x squared. 1 times 1 is going to give me 1. And then when I FOIL out, my middle terms, we're also going to add up to 6x. And I'll reduce it down to 3x plus 1 squared. All right, thank you.
Again, in this example, we see a square term in front, and we see a square term in the back. So I'm automatically going to think special factoring technique. Now, it can't be a difference of two squares, because that's when there's only two terms and they're separated by subtraction, right? So I want to look for the perfect square trinomial. Well, the best thing to do here is just to kind of break it up like we do before. If I'm going to assume this is going to be a factor term by itself, then this would have to be 4x and 4x, right? And then this would have to be 3 and 3. However, if my inner and my outer are going to add to give me negative, then my two factors would have to be a negative, correct? All right. So do you guys agree 4x times 4x is 4x squared? Negative 3 times negative 3 is positive 9, right? But let's just make sure this is a perfect square trinomial. Do the inner terms add to give you negative 24? Do the inner terms add to give you negative 24? Yes. So therefore, I can write this as 4x minus 3 squared. And that would be your factored form. OK, so ladies and gentlemen, what I'd like to do is show you how to factor out 64x squared plus 16x plus 1. Now, the big problem with this one, or not the problem, but the big difference we see with this one, is we have a large coefficient for x squared, but our c is 1. But remember, if we just follow what we've been working on, if I just take my a times c, which would be 64 times 1, I'm going to get 64. And then what two numbers multiply to give you 64, but then add to give you 16? Well, we look at that, and that's going to be a perfect square trinomial, which would be 8 and 8. So therefore, how do we write this up, though? Because we can't write this as x plus 8 times x plus 8, right? Because x times x does not give you 64x squared, and 8 times 8 does not give you 1. So what we need to do is we need to realize that this 8 times 8, this multiplies to give us this 64x. So what I'm going to do is I'm just going to rewrite this as 8x plus 1 times 8x plus 1. Now let's go and check our work. Does 8x times 8x give us 64x squared? Yes. Does 1 times 1 give us 1? Yes. And then does 8x times 1 plus 8x times 1 give us 16x? Yes. So there we go. Welcome, ladies and gentlemen. So what I have here is 49x squared plus 14x plus 1. And what I'd like to do is show you how to factor this by using a perfect square trinomial. And automatically, when I'm looking at this, I see, you could use the AC method, but the AC method is actually not that bad because it's 49 times 1. So really, it's kind of like when A is equal to 1. It's just that our factors are going to be from up A rather than at C. But the next thing when factoring trinomial, you always want to look at, is my first and my last term, are those square terms? And if they are square terms, does the sum of those square terms add up to give you 14x? So let's go and take a look at it. If I'm going to write my two factors here, I would have 7x and 7x. I'm assuming these are going to be squares. And then this would be positive 1 times positive 1. Now, when I multiply here, does 1 times 7x and 7x plus times 1 add up to give me 14x? Yes, it does. So therefore, this is a perfect square trinomial that can now be factored into the product of two factors. And since these factors are the same, we like to write it as a binomial squared. So there you go, ladies and gentlemen. That is how you factor a perfect square trinomial. Thanks.
Welcome. What I want to do today is show you how to factor a trinomial. Now, when factoring a trinomial, the main important thing we want to do is see if we can factor out our greatest common factor. Now, remember, our greatest common factor is going to be a factor that we can factor out of each one of these terms. Now, each one of these terms we call a monomial. This is called a trinomial because there's 3 separate of them. So when factoring out your GCF, you got to make sure that that number or variable goes into all 3 of our terms. So if I look at my n here, I have an n squared and n, but since it's 600, this term does not have an n, I can't factor an n out of this trinomial. I next look at my numbers, and I'm going to look at the smallest number out of these 3 to see which factors would go into all 3 of these. And since these are all even numbers, I know 2 is a common factor. And I also started looking at these. I do a little math in my head, and I noticed that these are also all divisible by 3. But when I start doing my math, I want to see what is the largest number that goes into all 3 of them. And I ended up getting that answer to be 6. So I can evenly divide 6 into all 3 of these, but that's going to be the largest number that I can do that with. So what I'll do is I'm going to factor out a 6. And when I do that, I'm left with the 9n squared plus 60n plus 100. So now the next thing I'm going to do is I'm going to factor, and I'm going to use a little box method to show you my factoring. One thing we need to remember when we're dealing with factoring is we need to understand that when factoring a trinomial, especially in the quadratic type, we have ax squared plus bx plus c. All right? So when I'm going to be doing my factoring, what I'm going to do is I'm going to set up a little diagram here, and I'm going to multiply my a times my c, and then to find my middle term, I'm going to add it up into a times c and then to a times c. I'm trying to think here. Hold on one second. And then what 2 numbers multiply to give you c, and would then add up to give you b. So then it's going to be a times c, and then b will be my middle term. There you go. Little flutter here. Okay. So all it is what 2 numbers multiply to give you a times c, but then add up to give you our b term. So our b term here is going to be 60, and our a times c term is going to be 900. So what again, I'll say this one more time to make sure. What 2 numbers multiply to give us 900, but add to give us 60? Now, if you think of big numbers, you can kind of actually cancel out the zeros. You'd have what 2 numbers, add up to give you 6, but then multiply to give you, 90. And what we notice is, or add up to give you 6, but multiply to give you 90. What we see here is if we have 30 plus 30, those 2 numbers add up to give me 60, and they multiply to give me 900. So that's going to be my 2 terms. Another thing that I noticed when I'm looking at this is I also noticed that this is a perfect square and this is a perfect square. And that's something very important for you guys to understand, because I can automatically tell you I already know what the answer is by looking at those perfect squares. But what I'll do is I'll show you the long way, just so you guys can see, so you have practice with it. So what we're going to do is, since I noticed that 900 is my a times my c, 30, 30, and 60. What I'm going to do is I'm going to rewrite now my middle terms that I just figured out. So I'm going to have 6, parentheses, so I have 9n squared. Rather than writing 60n, I'm going to write 30n plus 30n. 30n plus 30n would give you 60n, right? I got the 30 plus the 30 from right here, plus 100. Okay, so all I really did was, by using this diamond method, what I was able to determine what I could rewrite my 2 middle terms are. Now what I'm going to do is I'm going to factor all of this inside here. I'm going to factor by grouping. So what I'm going to do is I'm going to group the first two terms and then group the last two terms. Now what I'm going to do from here is factor out what I can for my first two terms. So here I can factor out a 3n. When I factor out a 3n, I'm just left with another 3n plus 10. Here, what can I factor out? Well, I can factor out a positive 10. And then what I'm left over with is going to be, again, a 3n plus 10. Now, what I notice, say, what can I factor out of these two terms? Well, I can both factor out. You notice that 3n plus 10 and 3n plus 10 are the same. So now I can factor that out. So my final answer is going to be 6n times a 3n plus 10 factored out times a 3n plus 10. Well, 3n plus 10, let's put parentheses around it. 3n plus 10 times 3n plus 10 is 3n plus 10 squared. So I'll just have 3n plus 10 squared. Oops. And again, I just used the brackets just so I wouldn't get you guys too confused by leaving it there. But, I factor out my 6, and I just want to use brackets so you guys weren't seeing so many parentheses. But your final answer would be 6 times 3n plus 10 squared. And that's it.